Hello, this is Jack Jackson. Let's talk some more about some special kinds of quadrilaterals. So here, once again, is a general quadrilateral. And one of the things I want you to notice is that we have diagonals. If we draw a diagonal, either that one or that one, we split the quadrilateral into two triangles. So the diagonal along with the sides of the quadrilateral form two triangles. So one thing that might be interesting is if these triangles had some particular property. Like, for example, what if these two triangles were congruent to each other, which they clearly are not at the moment, but maybe we could make them congruent. Let's see. It's going to be kind of hard to do here, just doing it like this, but let's suppose we could make them congruent. Wouldn't that be an interesting thing? So I have this by number and position of congruent sides. So how many different ways can you make the triangles congruent? Now remember, a congruence is more than just saying the two triangles are congruent. It's saying how and why they're congruent. So for example, if we draw this first diagonal AC, then we could have triangle ABC formed and also triangle ACD. Well, how many different ways could those triangles possibly be congruent to each other? Do you know the answer? Did you say 2 ways, 3, 4, 5, 6? There's actually 6 different ways. Because if we take the triangle ABC, there's 6 different ways we can make the vertices correspond to each other. Okay, so this may or may not actually happen, but we could have any one of these 6 congruent things, or perhaps maybe more than one of those. The first one says triangle ABC is congruent to triangle CDA. It's not only just saying those two triangles are congruent, but the angle at A in the one triangle is congruent to the angle at C in the other one. The angles at D and B are congruent, and the angle at A is congruent to the angle C in the other one, okay? And then side AB is congruent to side CD, and so forth. All the corresponding parts of those two triangles must be congruent, okay? Or we could write these 3 letters in different orders on the right side, and that gives us all of our different ones. If we reorder the letters on the left, we'd end up ultimately with some duplications, even though it may be written a different way. Okay, well, 2 classes of this are particularly important that we end up studying a lot, even in a high school geometry class. Okay, and here they are. The first one is this one. ABC is congruent to ADC. So the 2 angles at A are congruent, the 2 angles at B and D are congruent, and the 2 different angles we have at C are congruent. Side AB is congruent to side AD. Side BC is congruent to side DC. This is a class of figures that we call a kite, and it has a reflective symmetry. So if you're thinking of these triangles as being congruent by mapping one to the other, how do we map triangle ABC onto the other triangle ADC? We map it so that A corresponds to A, C corresponds to C, and B corresponds to D. In other words, we take what was called this major diagonal, the line through this line segment from A to C, or even the line containing that A and C, and we use that as a mirror line and reflect this quadrilateral over that mirror line, and we end up with the same one, right? So this segment AD is congruent to segment AB, segment DC is congruent to BC, and of course then the line segment AC is congruent to itself, and we have a reflection with congruent with the reflection. All right, here's another option here. Triangle ABC is congruent to triangle CDA. It's still congruent to the 2 triangles congruent, but they're a different way this time. This time, angle A is congruent to angle C. Angle B is congruent to angle D, and angle C is congruent to angle A. AB is not equal to AD anymore in length. AB is congruent to CD. They have the same length. So AB and then CD. So this one has opposite sides congruent. This one's going to have adjacent sides congruent. Well, that one turns out to be like this. It has rotational symmetry about that point. Okay, so let's see if we can look at our examples here. and there are various different ways that you can do congruent triangles. Okay, I've actually got all 6 possibilities here, and even a couple of even more special cases of that. So the first one is a kite. Okay, so we can, here's our mirror line of symmetry. So yeah, there's our mirror line of symmetry, and we can see this reflects over. So if I, for example, if I take obviously A and C, if they reflect over that line, they're not moved, they're fixed points. But if I show that B goes to D here, I can do that. So let's just do that with a reflection. Reflect about a line, take the point B and reflect about that line. Notice that that point here actually comes up and becomes, this point K7, turns out to be the same as D. Okay, so that's reflective symmetry. In fact, that's the easiest way to build a kite, is just to build a general triangle ABC and then get that mirror line and reflect it across that mirror line, no matter where it is. Okay, so that's got a lot of interesting properties. And notice it is congruent, as we've said. So angle, let's look at the angles. Okay, there we have that. But this one is bisected here, so angle BAC is the same size as angle DAC. And we got an angle bisector at this end. You get 2 congruent angles, or a pair of congruent angles, these 2 purple ones here at B and D. And so we get that. Okay, so that's an interesting one that we'll come back and look at that a little bit more. Okay, another important one is this one. So this one, okay, if we take this and look at the 2 diagonals here, find that point of intersection. This time we're rotating it around. So C rotates around to A, D rotates around to B. So angle, let's see here. ABC triangle is congruent to CDA. So angle A should be congruent to angle C. So angle A in the first triangle, that's BAC, BAC, angle form, extend those out into rays. That angle right here, it should be congruent to the angle over up here at C going the other way, right? So I can actually measure those. So this angle here should be congruent to this angle here. I need to measure that one as between 0 and 180 degrees. So notice those two have the same size. See that? Okay, and the way this works out, of course, so we're rotating around this point X where the diagonals meet. Let's go ahead and show you that. Let's rotate to, say, B around that point. So we're going to rotate around a point. We're going to rotate that around that point by 180 degrees in either direction. Look where it ends up. See, the corresponding point is over here at D from B, and A is going to rotate up to C and so forth. Okay, so if we just take the one diagonal, now we have 2 congruent triangles there. Turns out, in this particular case, the other diagonal gives us 2 congruent triangles as well. So we've got some opposite sides congruent this time. And these angles like this are congruent. Okay, there are some other special cases. If ABC is congruent to ACD, let's see what happens. AB and AC are the same length. Let's just go ahead and draw it. So it looks like this. AB and AC are the same length. See that? So now the diagonal is congruent to one of the sides. What else do we have? We have BC is congruent to DA. So you got two sides here that are congruent. What else do we have? We have AC is congruent to AD. Oh, well, what does that mean? That means all three of these are the same size. So this turns out to be a kite where one of the diagonals, the major diagonal actually, is the same length as two of the sides. So you got the two sides and the diagonal are all congruent to each other. This one, this one, this one, and this one. Notice that's kind of a special case of this kite situation where we had the kite situation here. What do we have? We have two pair of congruent sides that are consecutive. This is really the same thing on this one. ABC is congruent to DAC. It's just kind of a different labeling, but it's basically the same thing. Two others are special cases of parallelograms. Okay, if ABC is congruent to DCA, look what we have. We have AB congruent to DC. AB, here it is, congruent to DC. So we got a pair of opposite sides that are congruent. What else do we have? We have BC is congruent to CA. Okay, so the diagonal and this side are congruent. And then, what's the other one here? AC is congruent to DA. AC, that's here, the diagonal, and DA is the side here. So that means that since this one is congruent to both this side and that one, all of these blue ones here, this side, and the diagonal are all congruent to each other. So it's a parallelogram, again, as it turns out, with a pair of, with a total of two congruent sides here that are opposite, and the diagonal is congruent to one of them, and then the other sides are going to be congruent too. So that's kind of interesting, and it turns out the sides are parallel. We could show that later. Here's another special case. ABC is congruent to ADC, and ABC is congruent to CDA. This has both the properties of this rotational symmetry here and the reflective symmetry here. If it has both of those, it's actually a rhombus, which is a figure that has all of its sides the same length. This is going to have the properties of both a kite and a parallelogram. And an even more special case of that, ABC is congruent to ADC, and ABC is congruent to CDA, and ABC is congruent to DCA. That's another rhombus again, but this time the diagonal there is congruent to the others. This one you basically get by taking two equilateral triangles and sort of mashing them together, and the outside becomes a rhombus. If you're familiar with pattern blocks that you may have seen in elementary school, there's a pattern block that looks like this, and there's also some equilateral triangles that'll fit inside it, just like this picture right here. So that shows you some of the different ways that we can get triangles to be congruent. And in particular, though, we want to spend a little bit of time talking about these particular classes in the next few videos. Actually, we're going to first talk about kites quite a bit here in the next video. And we'll talk about parallelograms next week in our next playlist. Okay? So we'll talk about kites in our next video.